Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 5 in a lesson on how to find horizontal asymptotes. So we already looked at how to find x-intercepts, y-intercepts, and vertical asymptotes. Now, horizontal asymptotes, which you can say HA. That's what that stands for. So remember, to find the vertical asymptote, we just set the denominator equal to 0, but for the horizontal one, that's not what you do. You do something different. So obviously horizontal means that it would be like that instead of like that. It's hopefully you know the difference between those, horizontal, vertical, but just in case you didn't, that's what it is. So there's three situations. Okay, so the three situations that change what you do to find it. So let's just say that we had so let's just say that A represents the degree of a numerator. Num degree. Num deg. I'll just say that. And let's say that B represents the denominator's degree. So knowing what a degree is goes back to the last unit. Remember, if you have something like this, the degree is 2 because that's the highest exponent there. So if we had something like this, then the numerator degree would be 2 and the denominator degree would be 1 because there's a 1 there even though there's nothing there. That's review. So if the numerator's degree is less than B, then what you do is the horizontal asymptote is y equals 0. So the horizontal asymptote is y equals 0 if the numerator degree is less than the denominator degree. But if they're equal, you just simplify A divided by B. So, or sorry, that's not exactly, let's just say, that it's not the degrees that you simplify, you do the numerator coefficient divided by the denominator coefficient. We'll look at examples in a minute. And if A is greater than B, then no asymptote. So horizontal asymptote equals not NA, not applicable. So we can look at examples and figure out what it would be, which one we would do. So since we didn't even end up taking up that much space, I'll just erase this, and I'll just box in a thing right here for examples. So let's say we had x divided by x squared minus 9. What is the horizontal asymptote? So let's look at A and B and figure out what A and B are. A is the degree of the numerator. There's nothing there, so that means it's 1. And the denominator degree is 2. We see that. So B is greater than A, or A is less than B. So that means that the horizontal asymptote of this rational expression is, well, if we actually put a y on it, we'll just say this rational function is 0. Okay? Let's look at a different example. Let's say we had how about 12x to the 5th minus 1 divided by 3x to the 5th minus 4. So what is A? A is 5, because that's the degree. And same thing for b, it's also 5. Since they're equal, the horizontal asymptote is the numerator coefficient divided by the denominator coefficient. So 12 divided by 3, which means 4. So the horizontal asymptote is 4. Pretty simple. Okay, now let's look at a different one. How about x squared divided by x minus 9? Okay, that's a, so a is 2, and there's really a 1 there, so b is 1. That means that a is greater, so that means there is no horizontal asymptote. So pretty much that, or NA, it's not there. It's not a real thing. So that's how you find the horizontal asymptotes. All you have to do is look at the degrees of the numerator and denominator and then figure out what you need to do. Is it equal to 0? Do you need to do that? Or is it not even a thing? So that'll be it for this video, and I'll see you on the next video.